This is Siam. In this video, I'm going to explain how we can use the substitution rule when we're working with definite integrals. And for definite integrals, the formula looks like this. That means instead of switching back to x at the end, we can just change the limits to match our new variable u. So let's look at an example to see how this works. So our example here is the integral as 0 goes to 1, x times x squared plus 1 cubed dx. And we can see that there's an inner function of x squared plus 1 raised to a third power. And it's the derivative of that inner function is 2x. So that tells us that substitution will work nicely here. So let's let u be x squared plus 1. And then du will be 2x dx. And here we only have an x dx in our integral, not a 2x dx. So I'll multiply 2 here and then divide by 2 here, which is 1 over 2. So now, let's look at this u. In this u, if x is 0, u is u squared plus 1, which is 1. And when x is 1, u is 1 squared plus 1, which is 2. So we can rewrite this integral again, because we can replace u in here, and du is 2x dx, so we can just replace it here. So let's rewrite this, bring back the half from here. Integral. Now it will be 1 to 2, because that's what our u is. And we have u cubed, because it's raised to the third power, and du, 'cause that's our 2x dx. And let's find the integral of that. U cubed is basically u fourth to the fourth power, the antiderivative. And let's do this find this from 1 to 2, 1 to 2, yeah. So I'll pick a different color. Let's find 1/2 times u fourth to the fourth, which we can simplify it as 1 u to the fourth power over 8. And we gotta find that from 2 to 1. So let's do that. U to the fourth, but let's do with 2. 8 minus 1 to the fourth over 8. And that's 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Divided by 8, and 1 is just, yeah. 16 minus 1 is 15. It's 15 over 8. And that's our final answer. Yes. So the value of our definite integral is 15 over 8. To summarize, when using substitution with definite integrals, you still make the same substitution, but you also change your limits of integration to match your new variable u. That way you don't have to go back to x at the end. And that's how substitution works for definite integrals. Thank you.